Channel. So today we are going to understand this lead code problem. So this is a today contest problem, and the question is really interesting and tricky because it gives you the concept of matrix exponential and a lot of things to understand in the intuition. So let's read this question so we can go through the step by step. Okay, what question is saying? Question saying we have given string s consists of lowercase English letter and integer t representing the number of transitions to perform an array of size 26. So in one transformation, every character in s is replaced according to the following rules. So we have to replace s at I with next s at I minus a, right? Consecutive characters in the alphabet, right? We have to replace s at I with the next nums at s at I minus a consecutive characters in the alphabet. For example, if s at I is a and nums at 0 is 3, the character a transform into the next three consecutive character ahead of it, which results to b, c, d. Gotcha? Means if a character at an index I is a, right, and we have given nums at 0 is 3, what does it mean? Means 3 character. What, how many character? 3 consecutive character after a is b, c, d, right? In that form it will be get transforms, right? Transform. The next rule is saying the transformation wraps around the alphabet if it exceeds G. For example, if string char at I, right, equal to Y, nums at 24 is 3. So the character Y transforms into next 3 consecutive characters ahead of it, which results into, because it was Y, so next 3 character will become what? ZAB, right? And after that you have to return the length of resulting string after exactly t transformations. So don't get confused from the study problem that was the same was there, but the transformation one was there, and it was saying if z what is the name, g is there and if y is there, right? So you have to transform y into g. That is not the problem. This is different one. Okay, now understand, since the answer may be very large, we have to take a modulo of 10 to the power 9 plus 7, and then you have to return the length of the resulting string, right? So if you pause this video and if you go through the problem statement, it will be better for us to go ahead. Okay, either if you understand, let's continue. So what we have given? We have given a string of s of lowercase English letters and an integer t, that is number of transformations, an array number of nums at size 26. For each value tells us how many characters each letter should transform into, right? So for example, let's go with this first example. What we have given? The first s we have given as a string of lowercase English letter and t number of transformations, right? And this is the nums that we have given, like you can say nums having size of 26. If you count from here to here, the size is 26. Means each value that you can see in the nums tells us that how many character each letter should transform into. Okay, that we will understand right now. Okay, so let's assume that we have a, b, c and y in string s, right? And how many transformation we have to need to do? 2, right? So let's understand the first transformation, t equal to 1. When t is 1, right, t is equal to 1, then what we need to do? We have to do that the first character in the string is a, right, and we have to make it b. So a becomes b because nums as at 0 is 1. If you observe this one, nums at 1 is 0, right? Now think about the other characters. Similarly, the other characters is B in the string. So B becomes C because nums at 1 is this, and so on. We have for C, Y. So if you observe till here, right, we are getting 2 times Y, right? And so it becomes GZ because nums at 24 is 1, 1, right? So string after first transformation, it becomes B, C, D, G, G. Okay, let's go with the, now you don't need to consider this string, right? You now have to understand the S have, after the first transformation, the string becomes what? B, C, D, G, Z. Now make a condition over the second transformations, right? We will traverse all the elements again in this from the string and will transform it. So let's work B, C, D. It becomes similarly for nums having one value, so it becomes the next character. So B becomes C, D become D, D become E. Again it is coming ZZ. So what we can do now, YY not coming, ZZ coming, so Z become what? Two characters. Nums at 25 is 2, right? It means 2 characters ahead we have to transform. So Z will become what? G, after G, A to Z, right? After that no character is there, so it will move to the, it will move into the cycle. It will come to the A and B. Similarly, it will become A and B. Why? Because it look like G is the end, right? But no, we have to go ahead after G, means we have to come again at the index of nums 1 and nums 0 and 1, right? And so we can say A and B, right? Because 2 character after G is A and B. Okay, means we have to come to the next index of what? Nums. Okay, so after the transformation, if you calculate all the string characters that we have transformed, it become what? C, D, E, A, B, A, B, right? So if you find the length of this, right, so C, D, E is 3 character, A, B, A, B is 4 character, and so the length will become what? 7 character, and we have to return this answer, right? So what you have observed? So you have observed that every character S at I is replaced in the next nums at I minus A. If you do so, it is transforming in the first transformations, right? Just it is transforming, right? It means we are wrapping around G to A, right? So we will repeat this T times and will return the length of the final string. How many transformation is there doesn't matter. We will transform it and will return the length, right? Since the answer can be very large, right, we have to take the modulo of 10 to the power 9 plus 7 and then we have to return the answer. Okay, I hope you have understood this transformation 1 and transformation 2 of the example 1 that I was talking about. Okay, so if we'll talk about why is the brute force approach will apply or not, right? We should apply. Why is the brute force approach? We should apply or not. See, it is already saying we have to take the modulus because there the answer may be very large, right? So when if you talk about the very large, right, it will slow, right? The brute force approach will be slow. Then the question will come to your mind: why is the brute force approach is slow, right? So let's talk about the intuition, right? So the first thing that your mind will say that naive approach would apply the transformation T times, right? Because there are T times we have given the transformations, right? And so we can apply that at each one character at a time, and then will return, right? But wait, if T has let's suppose 1 billion time, right? 1 billion transformations times, right? We have given, right? If T is, here T means transformation, so if there is 2, but if transformations that we are doing for each character, if it is 1 billion, so each step can make a string longer, right? If you observe this string is getting bigger at each transformations, right? Means at each step it can make a string longer and the time complexity explodes, right? So what is the solution here? We need a smarter way to compute how the letter counts, right? As you can see here, and we have to think like smarter way, right? Means we have to compute how the letter count evolve over t steps that we have given, right? As you can see here, right? Without littering, you can say we will simulate all of them at one place and will compute that we have to think. So there is a smarter trick in DSA that is called matrix exponential, and that we will talk more in this video. Okay, so let's continue. Right, for example, we have s equal to ab, that is an initial string we can take, and t is 2, means 2 transformations we need, right? So for example, if we'll say nums, we have like this 1 1 0 and so on till the 0. Okay, so only a and b we have to transform, and rest of the thing we don't need to do anything, right? Means a we have to do b have to do c, and all others we don't need to do anything. Just what we will do? Nothing, right? So we are dealing only with the letters a to c for now, right? Because a is becoming b and b becoming c, right? Means we are dealing with a to c letters, not to further like d to g. We are not doing anything. We are doing these things, right? So initial, if you talk about what will become the in this case, what will happen, right? Okay, so if s we have given ab and our count vector will make, right? Let's suppose we'll say that count vector we got 1 a for 1 and b for 1, right? And c we don't do anything, so 0 and so on, right? So that we will do. So let's suppose we'll take the step 1 where we'll count, we'll take an initial count vector, right? And how we are going to map the to the indices? So we'll say a 0, b 1 and c 2. So after checking the frequency vector, right, what will go? What 1 1 0 means 1 for a, 1 for b and 0 for c, right? So this way we will create our count vector and we can represent like this. Okay, so in the step 2 we will transform matrix T, let's suppose, for each column in T, and tells us how a letter transform, right? So if we will do the transformation rule over here, so we are doing b we are doing c, right? So when we are transforming a into b, so matrix, or you can say transformation matrix 1 0 plus equal to 1, and transformation matrix T2 at 1 plus equal to will do 1, right? And all other elements we will not do anything, we'll do no transformations, right? So the transformation after applying these rules, what will happen? So from a we will mark what 0 0 0, then we will make from b what 1 0 0, and from c it will become what 0 1 0. Like this we will do, right? Because we are doing what we are doing at 1 0 means 1, 1 0 1 0 means 1, a becomes 1 b, right? And 2 1 means become 1 1 means b, right? And b becomes 1, right? That is c. Like this we'll do. You understand, right? What we are doing? So when we are writing t at means t means matrix at 1 0, right? What does it mean? So if matrix at t 0 matrix at 1 0 is 1, it means there is a, right? There is a, and it becomes 1 means it becomes b, right? So a is becoming b. Similarly, t at 2 t you can say matrix at 2 1, it means what? B is becoming c. It means t 2 1 is what? Matrix at 2 1 is 1, means it's b, and it becomes c, means 1c. So you can say 1b 1c, right? And that is why we can represent like this, means from a it becomes 0 1 0, from b 1 0 0, and from c it becomes 0 1 0, abc, right? I hope you understand, right? So this way we will transform once multiplying vector by t, right? So there is a formula, right? What you can do, t t into v0 will do the final vector, right? How we are going to compute it means t to the power t into v0 means vector. We'll multiply this and we'll find the vector. So why we are doing this? To apply the matrix exponential, because it may be a too big, right? Transformation can be many millions of transformation can happen for this problem, right? And so this is the way to find the matrix exponential. We have to apply and we have to compute in such a way we will find the final vector. And to find the final vector, number of t to the power t into v0 means vector, will apply and will find the vector. So let's suppose if here t is 2, so how will compute? So t to the power 2 means t into t, right? So you know matrix multiplication, right? So if you do the matrix multiplications, for example, if matrix is 0 0 1 0 0 0 1 0, if this is the matrix, if you'll do matrix multiplication, you will do like this, right? And you will find what? 0 0 0 for row 1, 0 0 0 for row 2, and 1 0 0 for row 3. And so the final matrix for T2 will become what? 0 0 0 0 0 0 1 0 0, right? Like this you will have. You understand, right? Because we are multiplying, we are repeating how many times? The t times. And for the t times, for t is 2, and that is why we are multiplying we will compute t2 and then we will multiply the given vector. Okay, so this is also called the magic of matrix exponential, and will compute by squaring it, right? So using the binary exponential, it will give you the O of log t, the number of transformation you have given. So the complexity will come because we are multiplying that time, so it will process for that time. And so log t means log matrix O of log t, you can say, is the computation for this time complexity will happen. Okay, let's understand the final applying vector, because if you want to do applying the matrix exponential, you have to apply this formula, right? And to do that, you have to apply the final vector t square into vector. It means if the vector is 1 1 0, you know the t square you have computed. So row 1 we have already calculated, as you can see here, right? 0 0 0 0 0 0 1 0 0, right? Like this we have row 1 2 3 we have given. You multiply with this vector, so all become 0 because the t square having at row is 0. Similarly for row 2, but at here we have 1 at this location, this cell, and we will get 1. So the result will become 0 0 1, right? So after 2 transformation, we have c equal to 1 times, means total character is 1. Okay, how many characters are there? So finally you will get the length of the character is 1. Okay, so if we'll talk about the summary, right, how we are going to do that. So we'll take a and b and we'll transform like 1 1 0. We'll build matrix t, will represent how many each letter or will transform to others. After the matrix exponential, we'll raise t to the power t, and we'll calculate t square or whatever the matrix exponential we have. And finally we'll multiply with the vector and we'll get the final result, and you'll find the length of the matrix, right? So let's do some hands dirty with the code, but before that let's understand some steps to implement that. Brute force idea is not good because that is not feasible, right? Because that can be many transformation possible, right? So what we have to focus, right? We have to focus on the count, not the content. So instead of keeping the string, just track how many each letter you have at any point, and think of the string as 26 vector. We'll count vector at I, how many times we have appears, right? And for example, we'll take this and we'll count, let's suppose a and b is coming 1 1 and rest of the thing is coming 0 0, right? So for the first transformation or one transformation, for each character a at I plus a plus character at this position plus I becomes nums at I characters. So number of times how many characters it will transform, that will be we can take from the nums at I, means add the character plus I plus 1 it will go over 26, right? And then at A we'll do I plus 2 and so on, and we'll take the modulo, right? Similarly for the 26. So you can, so that each character will becomes the next character for the each transformations, right? So we can model this as a transitions character at A plus I that will split it count to multiple characters and will represent in this transformation matrix, right? So let's build up step one. So to build the step one transition matrix, what we will do, we'll create a 26 into 26 matrix T. So let's suppose this is matrix T Ij. So number of ways the character, let's suppose A plus I will compute A plus J in one transformation. So for each loop, what we will do, we'll go for 0 to 26 indexes, and then for each you can say J, it will go to the number of I, nums at I, right? So nums at I is what, that given value. For example, how many characters we have to move. So if S at we have A, but nums at S at 0, let's suppose A, and nums at 0 we have let's suppose 1, right? So only one character we have to move. So only one character we will do it. So int target will find like this, and then we'll update the matrix value, right? So matrix at I and target will do plus plus. It will increase the you can say frequency, or you can say the count. Okay. Similarly, we'll raise the matrix to the power of T, that you have seen how to do that. We will apply T to the power T, means number of transitions we will do, transformation we will do, and will find the matrix, right? After that, you will apply the matrix exponentially, and that will take O of log T times, as I told you, right? Then we'll multiply with the initial vector, right? So if the initial vector is there, so you already have the matrix to the power T, right? Means let's suppose t square. So 2 times we have to matrix, we have to multiply. After that, we have the initial vector that you will multiply, and you will sum up all the counts that you have, and you will find the total length of the string, right? So code summary, if we'll talk about, we'll do what, count at I, how many times character we have, and that appears, and you will find the transitions at Ij, how many times A of I, A plus I becomes A plus J in one transformation, and we have to result sum of all the values in t to the power 2, let's suppose in this example, into count, how many counts are there, and you will find the result. Okay, so for the performance matrix, it will take O of 26 to the power 3, let's suppose, and matrix exponent will take O of log T, and the final multiplication if you do, let's suppose for this, so it will over 26, right, in to the power 2, and that will easily handle 10 to the power 9, because this is not much slow, right, and larger s dot length, right? So understand the problem again, go through, and let's go to the code, right? So first of all, what we have to do, we have to define the 10 to the power 9 plus 7 as a mode, and we'll take before returning the answer, right, we'll make a mode, we'll apply the modulus, and then we'll return the result, and we'll do that. For that, because the question is saying, right, now think of that we have a method length after transformation, where we have given input string, number of transformations, and the nums list that we have given. Okay, so first of all, what we need to do, we need to set up the frequency count, right? So how we are going to set up? So for that, let's suppose we have nums you can say array of 26 character of English letter in the lowercase, and we'll create the for loop, right, for the 26 letters, and we'll do nums at I, and we can get from what, the nums list, and we'll have the nums matrix, right, nums array. Okay, and so we can find how many transitions we have given at each characters, and we can get from here. So for that, you have to build the nums. Okay, after that, we have that we have to build the transition matrix, because you have the transition that will 26 into 26, as I told you in the step 2, right? So in the first step, we have to create the nums. In the second step, we have to build the transition, right? Why? Because see, nums we have created for the 26 character, right? And each character, how many transitions we have to do, for that we have to create, right? So we will initialize the frequency array for each character A to G, and for each character in the string S we have increment the count, right? That we will apply here. Okay, and for each character in the string S we will increment the count here, and will because this will tell you how many times each character currently appears, and you will do that, right? For example, if you'll talk about, let's suppose we have given S equal to ABC, right? So in this case we have given three characters, right? ABC in the S, right? So if you talk about the frequency at let's suppose for these nums, that is nothing but the frequency, right? So for this, let's suppose we have A, right? A we will store at the nums here what? 1. For B it will become 1. For C it become 1. So how many characters are there in this string will store in the nums, right? Because this is the frequency, right? For each character in the string S we increment this count and will store at where? Nums at here. So if you'll talk about the nums, what we have nums here? So nums at, if you'll talk about now after this loop, so nums at 0 is nothing but what? Now is 1, because in the string S A is coming only one time, right? And so nums at G 1 2 it also become 1 1. But if you'll talk about, if there is YY, it will become what? Let's suppose YY. So nums at, let's suppose 24, let's suppose 24, it will become what? 2. Okay, I think you understand, right? Next, think about building the transition, right? Why we are building the transition matrix? So first of all, think the transitions is 26 into 26, right? We are creating a 26 into 26 matrix because at column I it represents how letter I plus A transforms, right? If you remember, I used to write what? I, let's suppose I as a character, as an index, and A. So at column A, at column I, what it will represent? How letter I plus A transforms, right? Okay, so matrix to and from, matrix is what? T, right? So it was to and this was from, right? T 2 or 1, let's suppose, if we'll do, right? It means there will be some element, right? So there will be count. Count means one instance of from the produces count instance of 2. For example, if let's suppose if nums at A, how I can say, give me 1 second, that is why I am using this editor. Okay, so let's suppose if we have nums at A, I will do minus A. Okay, so this is 1. If we have given nums at A character and minus A character is 1, then what? Then A character like this, A character will be B, because there is only 1. Nums at this character is 1, it means A will transform into B, right? Means from to from, right? That we have to do. And so this matrix that we are talking about, so this matrix at this here, it will come what? From 1 to 0, and this will become what? 1, right? Understand or not? If you not understand, just think. Let's suppose like this. Okay, so just think, if similarly if we have what? We have G, right? If we have G, it means if I will write nums at this character, right? This is G, let's suppose G, and this is minus A will do, right? That will keep like this. Okay, so now how many characters is coming? Because it was coming 2 times, right? So it become what? 2, means it become 2. It means how we are transforming this letter? Means if we have G, we will transform into A, comma, B, right? That is rounding. So if G is coming, we are transforming into 2 character. And so if we'll write again here for this, let's suppose I'm going with the next line. So this was 0, this was 0, and this is 25 means from and to. So from 25 we are coming to 0, right? And so the matrix will also become, oh sorry, I left one thing. Okay, and so give me 1 second, I will write 1 and this will become 25 because G is converting into A and B, right? And so we have to write for B. For A, it is converting into what? G is converting into A and G is converting into B, right? I hope you understand this code, right? And let's continue. And for that, you have to create what? Matrix of 25 into 26 into 26 matrix, sorry, and will represent column at I. How many letters? Right? I plus A, right? Because matrix will add 2 from where and will represent the count. I think you understood this, right? So just pause this video and go through this step. It will help you to understand. Okay. Then for that, what we will do, we'll create a matrix here, right? 26 into 26 matrix. We'll go for the 26 character. We'll check on the nums at I. Then we'll find the next, where it will go to the next. So this is the transition matrix T that I was talking about, right? These are the transition matrix. So I means 2, from where it will come, that will compute like this. Okay, and you will have the transition like 1 and 2 will get updated like this if the character is Z coming A and B. Okay, so you will have this code. Okay, now think about the exponential transition matrix to power T. So T is what? Number of transformations given, right? So transition T is the matrix power will create a function and will provide here, right? So I'll show you later. This is a helper function or method, you can say. So we'll provide transitions and T. Transition, you know, this one, right? That we have created 26 into 26. Okay. So keep in mind everything. Means exponential transition matrix to power T. We will create this and we'll find transition T. Means we'll provide the T. Means let's suppose T is 2. So matrix will become matrix into matrix multiplication, right? And you will get the transition matrix. Okay. So this transition matrix we are doing only for matrix exponential. So this will compute the matrix raised to the power of T using the fast exponential, right? And instead of applying the transition matrix T, right, we compute mat to the power T, right? Mat to the power T. So if we'll go to the function, right, you can see, right? I'll explain it later, leave it. So just think that instead of applying the matrix, instead of applying the transition matrix T, we'll compute matrix at T that we have already seen, right? Matrix to the power T, right? That we'll do and we'll find this one. Okay. And this will give, because we are doing the logarithmic, right? Log to the power T, right? Power of T means log T times it will give the transformation, right? affect into the optimization, or you can say the processing. Okay, now think about initial character count from input string, and that you have the 26 character and you have the initials, means you will find the you can say frequency, right? So what you will do here, right? So you can multiply the string letter here, and for that you need the initials, right? So initial character count from the string you will find, let's suppose you can say frequency of each character in the string, you will have the initials. So that is required for the finding the multiply matrix with the initial factor. So initial factor means we are trying to multiply final matrix with the frequency vector. Okay, and for that we multiply the matrix t to the power t with the original frequency factor, and will return the result, right? That you have already know that we will have this and will multiply this, right? And you will add the sum to make take the mode, right? And finally you will have the taking mode and you will define the result. Okay, so each cell t at ij tells you how many I characters 1j represents, right? One character j character produces after t transformation, right? That I have shown you the example, right? Remember, we are doing what? Once you have everything, you are multiplying the final value after the t square is coming, then vector factor is coming, right? That part we are doing here and will return the result, right? And finally we'll compute the final answer and we'll return it. Okay, so we are wrapping with the mode. Okay, now think about the supporting function, right? Let's talk about the matrix power first, right? Because we have used here. So if we'll talk about this function, this is a binary exponential standard function and it will return the result, right? And because we are taking the result of 26 into 26, right? So we'll go for all the 26 later. Initially we will define as a 1, right? So if power is coming greater than 0, let's suppose coming 1 2 3 4 5, right? How many times we have given the power, means number of transformations we have given, that times this loop will go and will find the, you can say internally will apply the matrix multiplications, right? And will find the result and the matrix, and you will finally return the result, right? We will take the shift, right shift we will take and will return the result. How we will do that? You just pause this video and we understand, right? So the result starts as a identity matrix, right? And we are multiplying the matrix only when the bit is set power at 1, right? Power and 1, you can say. Okay, and the square matrix every time we are doing, right? And when we are doing the square of the matrix every time, right? Just to understand. So what is the identity matrix, right? So identity matrix we are doing here, right? You understand identity matrix. Identity matrix act as a one for matrix multiplication, right? And the matrix multiplication we will do here. Okay, so you have the result 26 into 26, then you will go for all the row and columns, you will find the characters, right? Each characters at ai bi will multiply, you will do the plus and you will keep updating the value. You are taking the mode here also. Okay, so this is a standard matrix multiplication. I think you will aware of, where you will taking the sum at this value and then you are taking a mode to ensure we don't overflow, right? So if you'll talk about what we are doing here, right? So first of all we are building a frequency vector of original string that been built 26 into 26 transformation matrix from nums, and then we are computing the exponential matrix to the power t, and then we will multiply you can say matrix to the power t with original frequency vector, and finally we'll do the sum and we'll return it. Okay, so that's all for today, guys. Let me know if you have any doubt in this video, and thank you for giving your time to understand. Okay, so it will take you the good runtime. Okay, thank you for watching this video.